And this is where we left off with the monocyte. One of the things that your book does real well, particularly with this, is it has a chart. I'm looking for the page here that lists all the white blood cells and actually red blood cell too and platelets. So all the cells, I see it as table 19.3. And what you want to do for the test is you want to make your own chart or redo this chart simpler, listing the cell, about how many, not in number, but know that most of the formed elements are red blood cells, and of the white blood cells, the most common is going to be your neutrophil. And then a little bit about what they look like. So whether they're a granulocyte, agranulocyte, what color they'll stain, and then definitely the functions of each, and then any unique ideas about each. That, for example, that the monocyte becomes a macrophage, and things that the basophil secretes histamine, and that the eosinophils have the ability to neutralize parasites, so things that are more than one cell. So some features about each, and have that table, and that's the way you want to you want to organize this information in your head for the test. This is I guess the bloodlines of the bloodlines, and particularly this is putting them all together. And I do believe it's image, it's not image 1911 any longer. It's actually image 1910 now, in the latest edition, but some of you might have the book where it's 1911. So we start out with this hemocytoblast. We've seen this before, and with this concept of colony stimulating factors, and you actually see colony stimulating factors throughout much of what happens in the body in terms of differentiation. Not something that I asked, but you have this myeloid stem cell line that is going to give rise to everything on the left. The lymphoid stem cell line is going to give rise to the lymphocytes and the actually just the lymphocytes, because even the myeloid stem cell line is going to give rise to the monocyte. So remember, those are the agranulocytes. That lymphocyte, we actually associate that with the lymphatic system. Comes from a different stem cell line, not the original progenitor cell, but a different stem cell line. And each time you have the colony stimulating factor and have a progression. I wouldn't worry too much about these lines. I would know the general fact that all of the formed elements except for the lymphocytes come from one line. Lymphocytes come from a line. If I happen to ask you the lymphoid cell, stem cell, I don't think that's going to throw you too far off because it's actually in the name. But then a few facts particularly about when they are functioning, because, for example, the red blood cells are released into the bloodstream immature as those reticulocytes, meaning they don't function then. And white blood cells also are released into the bloodstream as bands. They're not functioning yet. They're learning to function. And that kind of makes sense, I think, in a way, that they have to learn their job. And so they're released as immature, and circulate until they become mature. That's the formed elements. The last little formed element is a platelet, which is kind of interesting. We say platelet, and we also say thrombocyte. But really, in all honesty, ours are not called thrombocytes. Ours are called platelets. Because ours has no nucleus. They are fragments of this larger cell called a megakaryocyte. And it's really interesting. Not something that I will ask you on a test, but what the megakaryocyte does is kind of sections off little pieces of its cytoplasm, puts it in, packages it in proteins, and just releases it out, keeps kind of growing its cytoplasm and releasing these little portions, which are platelets circulating in our blood. And platelets have various functions. The creation of platelets is called this idea of thrombopoietin. And one of the platelet functions is the ability to release chemicals that start the clotting process. So clotting is their big job, and they release chemicals important to the clotting process that helps initiate and control the clotting process. They also form a temporary patch. They physically form a temporary patch in the walls of damaged vessels. They can actually stick to each other. They have this ability to stick, and they can also have filaments. They have actin and myosin filaments that can actually pull pieces of a cell wall together, thus shrinking a clot. Shrinking the need for clot, shrinking an opening. So they have certain functions which we think of them as in conjunction with clot formation, but they are some of the first to show up in clot formation. And speaking of clot formation, the idea of blood stopping is called hemostasis. And this does not come from your book, but I thought it was a nice simple one, and then we'll go into the ones that are in your book. And what you start at the top with an injury, so the endothelial cells are pulled apart and the basement membrane is then exposed. And that basement membrane is going to, you have exposed collagen fibers. And the platelets are sticky to the endothelial surfaces, which is kind of interesting because that can help them pull those endothelial surfaces together as long as they're not killed, as long as the cells aren't dead. And so that then begins what's known as the vasoconstriction phase, the vascular phase. And all of this happens because prostaglandins chemicals are released by that open area, so that those endothelial cells that have been pulled apart release prostaglandins, cause vasoconstriction. So you just have the vessel actually constricting, so a smaller hole would equal less blood pouring out just by that. Then that's the vascular phase, and that begins immediately, as well as the platelet phase begins immediately. What I mean about is within seconds, where you have platelets tend to stick to the endothelial cells. They tend to stick to each other. So you have this adhesion and a group of platelets sticking there, and that will cause a plug. And then what happens is about 30 seconds after the injury, you have this coagulation phase. So you have vascular phase, platelet phase, vascular phase first, platelet phase, and they're almost like within the blink of an eye. And then about 30 seconds after after the body is aware of the injury, you have the coagulation phase. And you have, with the coagulation phase, you have certain clotting factors, of which, please don't memorize clotting factors. The only ones you want to memorize really or know is this clotting cascade, thrombin, and that you have proenzymes. Fibrinogen is a proenzyme, meaning it's always circulating until it then turns into fibrin. Fibrin is what actually creates this blood clot. So those tend to be clotting factors you want to know: thrombin, fibrinogen, and fibrin. And then you have a blood clot, and then you have this antithrombotic, the control mechanism to get rid of the clot. you have plasmin that then works to dissolve the clot, which is something that we need to do. We can't hold on to that clot because it can cause a problem. We tend to divide this up into primary hemostasis and secondary. So this image does a pretty good job of dividing that up for you. Then we go into what you see in your book, your vascular phase. You just have constriction there of the vessel. And then the platelet phase, where you have the exposure, basement membrane, endothelial cell, platelets coming and adhere and sticking to each other and accumulating, and that makes the initial plug or clot, I guess you can say. And then the coagulation phase, and one of the things that I want to say about the coagulation phase is you have these pathways. The extrinsic pathway, which you see on the left, is immediate and it's very fast acting, but doesn't last long and doesn't produce a particularly large amount of factor X. At the very top you can see this factor X. Factor X is the key key component. I think they've measured there's about 20 different I guess no, it's more like 13 different factors. 10 tends to be the most important one, and many of the other factors are to create 10 because 10 will activate the extrinsic, 10 activates the intrinsic, and both of them can happen at the same time, that the extrinsic happens first, and then the common pathway is the one that gets activated last, and we're only talking about seconds here, and that is the one that you associate with thrombin, prothrombin, fibrin, fibrinogen giving rise to fibrin, and prothrombin giving rise to thrombin. The reason I say that is the pro and the fibrinogen are not active. They have to become activated for this. So extrinsic is first, fast acting, then the intrinsic, and then common pathway comes through is common pathway completes, I guess, the clotting process by converting fibrinogen to fibrin that then can capture all of these platelets and form a mesh that you're seeing there to the right, and then you also see here in kind of a whole, in its whole glory, where that fibrin is making those kind of rust-colored threads that all of these red blood cells, platelets, and white blood cells are getting caught in to make this final clot. And then at the end, you have clot retraction that actually pulls the edges of the torn vessel together after the cells have been taken away by white blood cells, and then you lyse the fibrin, so fibrinolysis, and that's done by plasmin. Plasmin isn't circulating all the time. You have a precursor to plasmin, a proenzyme, and that's plasminogen. So plasminogen then is produced by the common pathway to get rid of the clot. So the most important thing about the common path, other than all of these pathways are important, but it's that common pathway that releases the enzyme that can create plasmin that can then get rid of this clot in a timely fashion. We'll move on to the next chapter.